Hi, everybody. It's Dan Reus with EQ, and I'm here today with Mike Hill. Mike Hill is with Hill Innovative Solutions, and he does product development for a lot of folks, including a leader in the electric vehicle space.
Afternoon. Thanks for having me.
So you have an interesting journey. So you've worked in defense and tactical and security, product development and product management roles there. In the fitness industry, you've worked with hackers and makers, and now you're with Bytrode. You help them with their product development, and Bytrode is a company that provides equipment that kind of enable the electric vehicle industry. So tell me a little bit about what it's like to be a product person in such diverse sectors.
It's a lot of fun because every day is different, every project is different, and every market is different. And for a product person like myself, I really try to spend my time focusing on the process of the product as opposed to the actual product itself, which allows us to adapt the product to the industry or the market itself. You don't really become an expert at anything, but really the process itself. And so for product development, it really is just a matter of managing, justifying the product and bringing it to market.
So Mike, Bytrode has been around for 60 years. I'm sure they got started with lead acid batteries, and it was very basic stuff. Not to say that it wasn't probably really advanced at the time, but what are you doing now in the EV world? The battery technology has changed. It's changing rapidly. How it's used is changing. How does somebody that does testing equipment really feed the development of that cutting edge technology or make sure it scales out the door productively?
You're right. Battery technology is advancing rapidly, and as quickly as it's advancing, all of the characteristics of the battery itself is advancing, whether it's the battery management system, whether it's the chemistry itself and how quickly it reacts to create a charge or a discharge. So that's where the advancement in the battery testers is coming, is you've got to be able to move faster than the battery so that you can overcome the power that's being put out onto either into the tester or into the battery, so that you don't have some type of a catastrophic event. And testing isn't what it used to be. It used to be charge, discharge alone, but now you're wanting to understand a lot more of the characteristics of the battery, not just the charge cycles, but what does the temperature do? What is the pressure of the cells? How is the BMS responding and matching what is really happening inside the battery? So as the battery technology advances, the tester technology has to naturally advance with it. And that's where we're working right now is how do we take the advancements in power electronics and then control systems and integrate that back into the battery testing industry.
So does that mean then that the products that you work on in just the EV world are used in developing new technology, but also in demonstrating that it's working as intended on the line and on production vehicles after they leave the line?
So again, where Bytrode got its start was in the QA world for the battery testers. So how does the battery work once it's been produced? And do you have a reliable battery going into the system? And then the overall life cycle quality side of it. But very much on the other opposite end of the spectrum right now, with all the advances in battery chemistries, is how are those chemistries working? What different profiles can they have? Charge profiles, discharge profiles over the life of the battery, and how do the different chemistries work?
So you're trying to really preserve that chemistry for as long as possible over the life of a battery, because otherwise it's a really big paperweight, huh?
Yeah. So especially in electric vehicles, the battery life loses 40% within the first 2 years. And with only, 60% charge left, you don't have a battery. That battery needs to be replaced out of your EV system.
So the management systems and how you charge and how you discharge, it's not a simple thing because you're trying to bend that curve down on the 40% and extend the life of it, even as you try and increase the capacity to charge quickly and all of those things. So that's probably, you're managing a lot of things. There's probably way more metrics involved than people realize.
There's a lot more metrics. I think even with ranges getting up into the 500 miles now, there still is this range anxiety that exists with electric vehicles. And that's because there really isn't an infrastructure out for charging. So that's one aspect, is how long will it hold a charge, and how long can you drive on that charge? But then the other side of it is how quickly can it be charged? Even the extreme fast chargers that are out there, you're talking 30, 45 minutes. People aren't used to filling up their car for 30 to 45 minutes on gasoline. So how do you make that a competitive item or overcome that obstacle in the batteries? And that's, again, developing the battery itself to be able to take that type of abuse, because every time you charge it, you're heating it up and you're depleting some of the chemistry that's in there. So yeah, there's a lot of metrics being managed in the testing cycle.
You talked about the infrastructure, and, the infrastructure is not just the battery in the car or the vehicle. It's also, how, electricity is sourced and fed into the ecosystem, and how does it get around? And, there's some interesting stuff that even the oil companies are starting to realize, that maybe we passed peak oil, not from the perspective of how much oil is left in the ground, but because we can actually produce renewables at lower cost than we can extract and refine petroleum, that we're getting to that point. So once that happens and we start thinking about storage of electricity and moving it around to where it's needed, that's a change in thinking about what's in a car as energy and more as a technology that allows flexible use of energy. Can you talk a little bit about where else in that infrastructure, battery technology or storage technology that you're currently working with comes into play?
Yeah, for me, that's the most exciting part about working with EVs. It really is the technology that connects to the battery. It's the power electronics. And that's a very broad term, but it's still a very young term as far as all the advancements that are taking place, because there is a whole infrastructure side that is being built out, whether it's, like you said, the PV, the photovoltaic solar panels, collecting the energy, and then that energy needs to be converted. And it's the power electronics that do that conversion there. And then the distribution of the electricity. And so I think that that's where there's just, again, from a product opportunity side of things, that's where I get the most excited, because you've got this green energy action point that needs to be refined. While prices are coming down, they're right about the same level. They're not quite there yet, especially here in the Midwest, but they're getting there. And so reliability is going to be a key factor of that. And the reliability right now exists inside of the power electronics and the advances that happen there. The other side of it is what happens when all of a sudden we're not driving petroleum-based automobiles and we are dominantly electrification. What do we do for the power demand at that point in time, and where are we going to get that power from? So managing peak demand on the grid. Again, there's a whole infrastructure here that is wide open for innovation. Right now, everything, in my opinion, everything is being adapted to what's out there, and it's being adapted piecemeal. For instance, still to date, most of a manufacturing facility, I believe I heard a lecture a couple of years ago, more than 70% of the equipment inside of a manufacturing facility, more than 70% operates off of DC power. But yet we run AC power into the building and then we have to convert it. What happens when all of a sudden it's DC? Are we going to go DC to AC back to DC? Or are we going to find some unique way of actually integrating microgrids at a manufacturing level of you've got a completely DC microgrid running a DC based plant, and you're not tied to a power utility company anymore because all power is generated on site. I use that as an example because there is a plethora of innovation waiting to happen inside of this industry.
I'm reminded as we talk about this of, like how the auto industry got started, that it was all of these people working in their workshops and stuff, and gradually this industry emerged. Talk a little bit about what kinds of things that people are working on that there's a product and a market for in the future. What are the tinkerers working on that are kind of interesting opportunities?
There's two areas that I saw a lot of, not necessarily EV itself, but electrification of, skateboards and bikes and that type of stuff. Micromobility is definitely becoming a trend, especially as we're moving back into the cities again with new generations. you're seeing more and more of that, which there's going to need to be, again, some level of management of those devices. The other side is solar. I think that that's one that just has so many people excited, and a lot of people are hacking into that and figuring out ways. MIT just launched a new product where the solar panels don't look like standard solar panels anymore. They can take different shapes. They can take different appearance. So it looks just like a roof of a house as opposed to a bay of solar panels on top of a house. So there's all sorts of technology advancements coming out there. And again, there's only more to come.
Mike, talk a little bit about as a product person. So you're a fan of lean. You know, it's not just a way to meet, but it's actually a way to develop products and to improve them. Talk a little bit about how somebody can get started in this space. So take a product. So you talked about micromobility. Take a product in micromobility and think about all the ways that you could develop a product and really improve it rapidly.
Particularly in this industry where there is just a lot of open space for development, it really plays heavy to the lean and agile product development systems. There's a lot of iterations in the product development. So you get to that minimum viable product, you're able to get it to market, you're able to test it. So in a industry like this that's wide open, it really plays to, like I said, the lean and agile product development cycles, because there's you want to iterate, you want to get the customer feedback and understand the adoption prior to. So if you kind of break down, lean is the elimination of waste, and agile became popular because of its iterative approach, became popular in software and has moved into product-based items. The reason it became popular in software because it's really cheap to iterate software as opposed to a physical product where you've got actual material and labor costs into it. But now that makerspaces and manufacturing technology is becoming so advanced, to the additive manufacturing, 3D printing, so that you can prototype and iterate a lot faster, agile is becoming more popular in the product space. And I think that leveraging that approach in this space is what's going to allow for greater innovation, because it's going to get you customer feedback quicker. You're going to understand the industry faster, and you're going to understand what the actual usage and adoptions are going to look like.
So if you develop a vehicle that you've got the battery technology and you've got the control technology and everything to make it somewhat useful, every time you use it, you're going to get feedback on how to improve the charge cycle, how to improve discharge, how to improve range, how to improve longevity, how the customer actually uses it. You have a somewhat successful product, and it's just going to get more successful and more efficient as you go forward, right?
That's exactly right. Henry Ford said if he asked the customer what they want, they'd say a better buggy whip, right? You really don't know what the customer wants, because the customer doesn't really know what they want until they get it in their hands and they're able to actually practice and use it and apply it. So you're right. Everyone says that, I don't want an electric vehicle because of range anxiety, right? I don't know that it's going to last full cycle, but then when you break it down, they only drive 34 miles round trip. And so they can get home and charge it overnight, and that EV would easily suffice for them. But they don't think about it that way because they haven't been forced to use it that way, or they haven't tried using it that way. Getting these different iterations, getting them into the hands of customers is what's really going to drive the innovation in this industry over the next decade.
What about the infrastructure for the utilities to be robust enough to deliver power when it's needed, but also to be flexible enough to take all these inputs? Because if we really are going to get solar and wind and all of these micro inputs into it, I would imagine that the infrastructure for the utilities is going to become much more complex to meet this demand.
On both sides of it, you're right. The input and the demand side is going to take a hit. I heard a statistic. If only 13% of the current automotive industry moves to EV, the current grid infrastructure isn't enough to supply that amount of power. So you're right, the utility industries are going to have to adapt to that. On the input side, they're going to need to generate more power. Hopefully it is a green power. In doing so, more fossil, I don't think, is the answer. But definitely green is an opportunity. But again, I think that this is where innovation, it's open, right? It really is open. And I really do think, Some of the utility industries are already putting in microgrids so that they can run small towns off of their microgrid, or small subdivisions off the microgrid, that is primarily powered off of green with usually a backup or energy storage system. Energy storage systems are going to have to become more advanced. I know New York is already looking at advanced energy storage systems, so much so that FDNY has been putting out restrictions on size and storage requirements of the energy storage systems, because that's a lot of power sitting there that should something happen to it, something dangerous could happen. So, like I said, it's wide open for innovation. There's a lot of different thoughts to it. And the more people invest in solar for their homes and pull off the grid, the more that's going to help that. But again, that's a wide open industry and a very infant industry.
In that industry, do you see the big players playing well in that space, or do you think it's the upstarts that have opportunities?
I think with any disruptive innovation, the advantage always plays towards the strength of the startups, always plays to the entrepreneurs, because the big guys, while they're investing in it, right, and like in electric vehicles, Tesla's the famous one, but in reality, every auto manufacturer has an electric vehicle or has one in development with really good technology that is as good of, if not better than Tesla's. But again, the ships are almost too big to move fast enough to keep up with the disruptive technology. And I think you're going to see that play out across the entire landscape with the electrification of our systems and moving to green technologies.
What's something that's really interesting to you that you're seeing that you think is going to be really interesting to watch in the next 5 years? What's coming ahead?
With the advances in material technology, we talked about the solid state batteries, quantum batteries, but even on the power electronics side, the advancement in materials for the power switches with silicon carbide and gallium nitride, the materials are now getting there. It's going to be the integration of those materials into different applications. I think that's where the next innovations are there. The research, and I'll tell you right now that the government and different organizations like Power America have done a very great job. I don't want to say phenomenal and the government in the same sentence, but they have done a good job in funding the research to get this technology there. And now it really does put pressure on industry to apply the technology that's out there to what's next.
Maybe somebody that wants to be in this space, they could start paying attention to material science and start asking themselves, how does this innovation help with switching or charging or, power density or some of those kinds of things? What you're saying is those are all problems that are going to need to be resolved. We're on this path, but conceivably you said 13% of the grid, is adequate. Like 87% needs to be improved, right?
Yep.
That's a pretty big number. Do you see any places like either geographies or interesting labs where things are coming out of? You mentioned like MIT. Are there influencers people ought to be following in this area?
In this industry, it's so hard to look past Elon Musk. His name just comes up and he's at the forefront. He's done a great job making it impossible to look around him. But I will say that there is a lot of up and coming technology, believe it or not, coming out of China. CATL is a battery manufacturer that I've come to respect quite a bit. And their chief technology officer is actually out of Detroit. His name is Bob Gallion. He's doing a lot of great things with that, but I wouldn't say that they're necessarily breaking new ground as far as truly what is the next, quantum space, which is the startup out of California with the solid state batteries. The fact that you really can't point to anyone right now. You can point to a lot of small groups and small case studies like that. But the fact that you can't really point to, man, that's the guy that's really doing it, I think speaks even more to the fact that it is an industry open for innovation and what's next.
What about the infrastructure side of it? Is there somebody that's thinking about it either at a utility level or at the microgrid level that people could be following?
So the organization that I just think has been doing a phenomenal job, and that's Power America. They're in conjunction with NC State and their power electronics group, but there's several other universities that are involved with it, as well as several industry leaders. that are with it. And so Power America a few years ago funded a tremendous amount of research and development and has really worked to advance the infrastructure that's rolling out. I believe even Porsche's extreme fast chargers was partially funded by Power America. I know that there's other extreme fast chargers under development by the DOE and groups like that. You know, believe it or not, that is where a lot of it is coming from right now, is organizations like Power America and the Department of Energy.
So one last thing. You are active in the product community. You worked in the defense industry. You worked with companies that were developing enabling technologies for the defense manufacturers. You're now in this space. You also worked with a lot of people that are your makers and hackers and kind of visionaries. What do you think is something that we can expect to see in St. Louis or in any other city as an ecosystem to support this? Do you think there are dozens of companies, and what are those companies looking like?
First and foremost, I think the one thing that I've learned throughout my career is always expect the unexpected. It really does come out of left field. You never saw it coming. There's definitely companies out there. And the reason I know there's companies out there is because there's funding out there, which that's a great combination. The fact that there's money and the fact that there's people interested and pursuing it. Without a doubt, it's going to happen. I'd love for it to happen in St. Louis. Unfortunately, I don't see a lot of that happening in St. Louis, whereas there's a lot of research out of Boulder, Colorado and the University of Colorado Boulder, as well as NC State and like I said, Power America. So I think that as far as the power electronics and integration, those could be hot spots. You know, the other side of it also is Silicon Valley is still, especially in electric vehicles and charging stations, I think that they're still very much leading the way in developing innovation.
If I'm an investor and I have some early stage money to put into a startup in this space, or if I'm an entrepreneur hungry for an idea, what would be something I would say, hey, I would explore this space because this is going to be something in the next couple of years?
I would say machine learning has started to take its hold inside of manufacturing, but I would say that it has not quite hit the power electronics as much. The wonderful thing about power electronics is they usually have some type of processor control or sensory data already there. I would say that the integration of more intelligence onto the power electronics could be an opportunity.
Well, thanks, Mike. Anything that we didn't talk about that you think is just fascinating about the space?
I think right now it's just a fascinating space in general. It is very young on the S-curve, and there's a lot of space for innovation in the industry.
So we talk about EVs and we think of cars. Can you describe what the use cases are? Electrification happens in forklifts. It happens in, people are talking about in airplanes. Can you just talk about, like, when we say EVs, how many different modalities of transportation is that possibly in that we're looking at both now and in the near future?
I will say that there is more research in aerospace than most people are aware of, and I have seen that firsthand. I will say that maritime and submarines are beginning to integrate and utilize it as well, and then public transport, buses, as well as other carrying systems. It is a lot broader than automotive. You've seen the trucking industry and their projections of integration, but it's definitely a lot broader than that.
Great. Well, thanks, Mike. This has been a great conversation. You've given us some great areas to explore, everything from micromobility to submarines to airplanes, and how this area of power electronics is playing a part and how that's an opportunity for entrepreneurs and innovators. Thanks so much, and we'll talk again soon.
Thank you.